Right, so we're on to the C grade questions now. One more mark if we got everything else right, and we're there. Probability question. In a game, a player rolls a coin onto a board marked out in squares. The squares on the board are coloured red, blue, green. If a coin lies entirely within one of these coloured squares, the player wins a prize, otherwise the player loses. The table shows the probabilities of the coin landing entirely within each coloured square. So probabilities often measured using fractions, but can also be measured using decimals. The key thing is that the scale is always between 0 and 1. Impossibility is 0. The total possibilities must add up to 1. So the probability the player wins a prize. If he's going to land on red, the chances of him winning are 0.13, blue 0.14, green 0.04. Anything else, he's not going to win a prize. So the probability that he wins a prize is the total of those three outcomes. So that's like 13 pence, 14 pence and 4 pence. 0.27, 0.31. So the chances of him winning a prize is 0.31. One day, 200 people play the game. How many people would you expect to win a prize? So what you're going to do here is 0.31 times 200. The chances of one person winning would be 0.31. 2 people would be 2 lots of that, 3 people 3 lots of that, and so on. That's going to be the same as 2 lots of 31, which is 62. So 62 people are likely to win. It costs 70 pence to play the game once. The prize for winning is £1.50. If 200 people play the game once, how much profit do you expect the game to make? So those 200 people are all going to pay 70 pence. So that's how much the game brings in. The game pays in 200 lots of 70p. 2 lots of 200 lots of 70p is going to be 14 followed by 3 zeros. That's in pence. In pounds, you divide it by 100, be 140 pounds. We're expecting 62 people each to win £1.50. So game pays out 62 lots of £1.50. Well, 62 lots of a pound is 62 pounds. 62 lots of 50 pence would be 31 pounds. So 62 lots of £1.50 is the same as 62 plus a half of it, which is 93 pounds. So the game brings in 140 pounds and it's likely to have to pay out 93 pounds. So the profit will be the difference between those two. So 3 from 0 you can't do, so you have to borrow from the next one over. 3 from 10 you can do. 9 from 3 you can't, so you have to borrow from there. So you're going to be doing 9 from 13, which is 47. So the profit that you're expecting to get is 47 pounds. So the marks for that, you'll have a method mark for adding your probabilities together and an answer for the right answer. Here you'll have a method mark for multiplying your probability by 200 and 1 for the correct answer. And for this one you are going to get a method mark for a lot of work really. The mark is for you working out those two values and subtracting them. Excuse me again. So the method mark is for working out the 140 and the 93 and performing the subtraction, and the answer mark is for getting the £47. So a lot of work to do there for 2 marks. Okay, now we're on to angle properties. ABCD is a parallelogram with ADC equals 46. Now that method of describing an angle, you need to know basically the middle value is, the middle letter is where the angle is. So ADC is saying you're going from A to D and then travelling to C. So ADC 46 is at D, and ACB is 49. ACB is 59, sorry. Find the size of angle X. Well, you need to know that there's an angle property of a parallelogram that you need to know. Opposite angles in a parallelogram are equal. So if you didn't know that, you're going to struggle with this question. So that means that, if that angle is 46, that angle there is 46 as well. Now you know two angles inside a triangle. So angles in the triangle you also need to know add up to 180. So 59 plus 46 is 9 15, 105. So X is the missing angle, is going to be 180 less 105, which is 75 degrees. So the mark for that, you're going to get 1 mark for identifying the 46, 1 mark for adding those up and taking away from 180, and 1 mark for getting the right answer of 75. With this one, the property that you need to know is angles, 2 properties. Angles inside a quadrilateral add up to 360, and angles on a straight line add up to 180. So first of all, we can work out that one there. That's going to be 180 less 125, which is 55. Now we can add up the angles that we know and take them away from 360. So 117 plus 141 plus 55. So add those up. 6, 13, 5, 6, 10, 11, 313. So Y is going to be 360 less 313, which is 7 from 10 is 3 from 10, sorry, is 7, 1 from 5 is 4, 3 from 3 is nothing, so it's 47. So first of all, you're using 180 on a straight line to work that one out. Then you're adding those up to find the angles that you know inside the quadrilateral and taking that away from 360. So for that one, there's 1 mark for the 55 degrees, 1 mark for taking the sum away from 360, and 1 mark for your answer. So on that page, remember we only needed 1 mark for C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 marks in total. Question 13, timetable. The following is part of a train timetable from Bangor to Chester. So the train leaves Bangor at 7 minutes past 11, a different train leaves Bangor at 12:24, and a different train leaves Bangor at 7 minutes past 1 p.m. 13. This train reaches Llandudno Junction at 11:25, and so on down the timetable. So each column is a different train, each row is a different station. Bob catches the 11:31 train from Colwyn Bay. When should the train arrive at Prestatyn? So here's Colwyn Bay. So I'm looking at this row for the 11:31 train, which is there. What time does it arrive in Prestatyn? So he gets on it there. He's in Rhyl at 11:41. He's in Prestatyn at 11:47. Mary catches the 13:25 train at Llandudno Junction. How long should it take her to get to Chester? So Llandudno Junction is here. 13:25 train is there. It gets to Chester at 14:19. So arrives at Chester at 14:19. Now, it's not asking what time it arrives, it's asking how long it takes it to get there. Now, you can't subtract time in the same way you can with decimal numbers, because time isn't out of hundreds or tens, it's out of 60s. So you can't do a straightforward subtraction. So 14:19, 13:25, you've got to deal with yourself. Okay, it's less than an hour. How many minutes less than an hour is it? How far away from an hour? Well, an hour would be 14:25, so it's 6 minutes less than an hour. Yeah, if it leaves at 13:25, an hour on from that is 14:25. 6 minutes less than that, which is 54 minutes. So that's what you're looking for. So there's 1 mark for 11:47. There's 1 mark for spotting both of those and trying to work out the difference between them, and 1 mark for the correct answer. Express 240 as a product of prime numbers in index form. So this is a technique that you would need to learn. Basically, we're going to repeatedly divide 240 by prime numbers until we can do it no further. If a number is even, then we divide by 2. If a number ends in a 5, we divide by 5, and so on. So this one, 2 goes into that, 2 into 240, 120 times. 2 goes into that 60 times, 2 goes into that 30 times, 2 goes into that 15 times. I can't divide that by 2, but I can by 5. 5 goes into that 3 times. What we now have is a full string of prime numbers, so we don't need to do any further division. And in index form, we can write that as 2 times 2 times 2 times 2, which is 2 to the power of 4. So that's the index. 2 times 2 times 2 times 2 is 4, times 3 to the power of 1, because there's only one of them, times 5 to the power of 1, because there's only one of those. So you've got 1 for the method, 1 for the string of prime numbers, and then the last mark, because it's asking you for index form, you have to write it in that form. Question 16. Okay. The diagram shows the transformation of triangle A to triangle B. So something's happened to move that or change that from where it is to where it is. So there are the possible ones that we could be looking at. Translation, which means it's moved but stays exactly the same. enlargement or reduction, which means it's changed size. Well, it hasn't. It hasn't translated because it's been flipped. It could have been rotated, or it could have been reflected. Now, because these corners are all opposite each other, then the chances are it's been reflected. So it's a reflection. That'll get you 1 mark. To get the second mark, you need to say where the mirror is. Now, the mirror is going to be halfway between these two opposite sides. So if we've got 1, 2, 3, 4 squares gap between them, the mirror is going to be halfway, which is here. So we'd have a mirror being placed there, and that would then give you your reflection. And this line is known as the line y equals 1, because everywhere on that line the y coordinate is 1. So we'd say reflected in y equals 1. For a rotation, you're allowed to use tracing paper, and I recommend that you do so. So we're going to rotate triangle A, then it's going to give us some more information. It's going to tell us what angle to turn it through, so 90 degrees, a quarter of a turn. Then it has to tell us in which direction, because if you turn quarter of a turn that way, you're going to end up in a different place to if you turn quarter of a turn that way. So clockwise is the same direction the hands of a clock travel in, which are that way. So that's my 90 degree clockwise. And about the origin means that when it's turning, it's pivoting around that point there. So take your tracing paper, cover the shape, put an arrow pointing up the page, and it's triangle A we're going to rotate, so I'm going to trace now triangle A, and I'm going to pin this tracing paper down where it's telling me it's rotating through. So I'm going to pin it down until so that it rotates about the origin where I am. And I know that quarter of a turn clockwise means that that arrow is going to be pointing in that direction once it's performed that quarter of a turn. So pin your tracing paper down there, turn your tracing paper until the arrow is pointing that it's gone through a quarter of a turn, which is there. And that is where your rotation needs to stop. So once you've done it, then you need to make sure that you can see where beneath there the triangle is going to be. And again, use a pencil, because as you can see my pen's made a hell of a mess. So label your answer C. That's my answer C. Okay, so the marks for that question, you're looking for 1 mark for a reflection and 1 mark for telling me where it is. And then for your rotation, there are 2 marks for it being in the right place. So total for that page, 1, 2, 3, 4, 5, 6, 8, 10 marks on that page. Draw an enlargement of the shape below using the scale factor of 2. Now sometimes when they ask you to enlarge a shape, they'll give you a centre of enlargement. In this case it hasn't, which means I can enlarge it anywhere I like on that grid. So I'm just going to move it there. I'm going to start it there. This side is 1 square, so in the enlargement it's going to be twice as large, 2 squares. This one is 2 squares, so in the enlargement it's going to be 4 squares. Now to get to that point from there, I have to go down 2 and across 3. So in the enlargement, rather than down 2 across 3, I'm going to have to go down 4 1, 2, 3, 4, and across 6. 1, 2, 3, 4, 5, 6. So that is my enlargement of scale factor 2. 2 marks for that. Question 16. Sophie travels a distance of 35 miles in 2 hours 30 minutes through busy traffic. Calculate Sophie's average speed in miles per hour. So this is something you tend to do in science probably more often or just as often as in maths. So hopefully you know that speed is distance divided by time. So in this case, her distance is 35. Where you have to be super careful here is to remember, just as we did with the timetables question a couple of questions ago, that time isn't measured in the same way as decimals. So 2 hours 30 isn't 2.3, which is what they're expecting you to trip up with. 30 minutes is half an hour. So 2 hours 30 is 2.5 hours, which is 2.5 as a decimal. So what we have to do is 35 divided by 2.5. Now, 35 divided by 2.5 doesn't seem to be a very nice division to do. But if I double both of those, I get 70 divided by 5, which is easier. And so long as I double both of them, there's nothing wrong with doing that. So 70 divided by 5 is easier. 5 goes into 7 once, remainder 2. 5 goes into 20 4 times. So Sophie's average speed is 14 miles per hour. Okay, so we're up now at the last couple of questions in the paper. They're getting harder. So here they're testing your ability to remember the formula for speed, distance over time. They're testing your ability not to write 2 hours 30 as 2.3, and then doing a division which is a little bit more complicated than previously. For part B, they're also testing your ability to remember something, which is that the relationship between pounds and kilograms is that 1 kilogram is approximately, the squiggly equals means approximately, 2.2 pounds. That's LB, which is pounds. So 22 pounds is going to be 10 times that. So there's only 1 mark for that, and I don't think they were expecting many people to get that right, because not many students these days remember that relationship. So 1 mark for that one, and for the top one there's 1 mark for the 2.5, 1 mark for the division, and 1 mark for the correct answer. So 6 marks on that page. Then we have a stonking time question. We're really testing time on this paper. Sophie is due to fly from Glasgow to San Francisco. She arrives at Glasgow Airport on Wednesday at 13:40. She has to wait 4 hours 25 minutes for her flight. It takes 13 hours to fly between Glasgow and San Francisco. She knows that the time in Glasgow is 8 hours ahead of the time in San Francisco. On which day and at what time does Sophie expect to arrive in San Francisco Airport? You must show all your working. So the first thing to do here is not worry about the time difference, just work with Glasgow time. So she arrives at 13:40 and has to wait 4 hours 25 for her flight. So time of flight will be 1340 plus 4 hours will be 1740 plus 25 minutes so 20 minutes will take her to 18 o'clock plus another 5 is 18:05. So she flies at 18:05 Glasgow time. Now 18:05 Glasgow time in San Francisco is 8 hours earlier. So in Glasgow, in San Francisco, it's going to be 8 hours earlier than that, which is going to be 10:05. So she's going to be when she takes off, it's 10:05 in the morning in San Francisco, and her flight is going to be 13 hours. So she's going to arrive there 13 hours after that. So 10:05 in the morning plus 13 hours is going to be 23:05. So in San Francisco, it's still going to be on Wednesday, and it's going to be 11:05 in the evening. So that's quite nasty for only 3 marks. It's quite a lot to get your head around there for 3 marks. So one of the marks is for working with all the times. One of the marks is dealing with the time shift, and one of the marks is for getting the right answer. Ugh, horrible. Question 17. Oh, back to something nice like algebra. So we're up now to clear overlap with the higher tier papers. First of all, it's an equation. The first thing you have to do is get rid of the bracket. And you do that by multiplying the number outside the bracket by every term that's inside the bracket. So it's going to be 3 times x, 3 times 6 is 18. Then you want everything with letters on one side and everything with numbers on the other. So to get rid of the 3x from that side, I have to take 3x off, which means I have to take 3x off that side as well. To get rid of the number from that side, I've got to do the opposite of taking off 12, which is adding 12. So the 18 is still there, and now I have to add 12. 5x take away 3x is 2x, 18 add 12 is 30. Now to get rid of the 2, it's a times 2, so I have to do the opposite, which is dividing by 2. 30 divided by 2 is 15. Now with this question, rarely comes up on a foundation tier paper. Basically, you deal with the inequality in exactly the same way as the equal sign. So with this, we're just going to be working in exactly the same way as far as equations are concerned. So to get rid of the plus 5, we have to take off 5. So 9x is less than 72. To get rid of the 9, it's a times 9, so we have to divide by 9, which means x is less than 8. And that's it. So it's basically, don't worry about an inequality sign, deal with it in the same way in the foundation tier anyway deal with it in the same way as an equals. So marks for that: 1 mark for dealing with the bracket, 1 mark for getting it down as far as 2x is 30, 1 mark for the right answer, 1 mark for getting it down to 9x is less than 72, 1 mark for the answer, 8 marks for the page. And the final question on the paper, 4 marks. Given that XB is 2.5 centimeters, DC is 12 centimeters, and the area of triangle ADC is 60. So I know that that area is 60. Calculate the area of triangle XBC. So the area of a triangle is half base times height. So half times 12 times the height AD must equal 60. So we're working with triangle ADC. Half base is 12 times the height, which I don't know, is 60. Half of 12 is 6. So if that's an equation, to get the AD on its own, I'm going to divide by 6. So AD equals 10. So if that is 10, that is 10. So the area of XBC will be a half base 2.5 times height, which is 10. 10 times 2.5 is 25. Half of 25 is 12.5. So there's 2 stages to go from the question to the answer. So there's 2 marks for finding that height is 10, and then 1 mark for correctly using that to get the final answer. So 4 marks for that last question. So that's it. So they got quite fixated with time questions on that paper, which is unusual. There were a few there, and yeah, it was quite a challenging paper, but as I said right at the start, you needed 61 on it to be sure of a C.